Pod. Pod. You know, pod. Plan of day. Plan of day. Pod. Homework questions 312. We're going to go over homework 313. Take a quiz. Notes 313. Take a quiz. Homework 313. 312 homework questions. Anything. Or 311. I guess we could do that too, if you had anything. No questions? Y'all good? Yes, sir. On worksheet B or worksheet A? A. This one right here? Yes. So I like how they threw in cosine of x does not equal to 0. I'm sure they threw that in because cosine x is in the denominator. And so don't let that stuff confuse you or anything else. I think we have to know that cosine x is not 0 because that would put 0 in the denominator, and that's always bad. So they want which of the following is equivalent to this? And I got cosine squared x minus 1. And I know that sine squared plus cosine squared, again, sometimes we need to go over here and say sine squared plus cosine squared equals 1. Anytime I see ones with cosines or sines and their squares, typically I'm going to end up using one of those Pythagorean identities. It says cosine squared minus 1. So if I did that, I would actually have to put the 1 over here. And then that would give me cosine squared minus 1. And so then I got to put the sine squared over here, which would actually make it a negative sine squared. And so cosine squared x minus 1 is a negative sine squared x, just all by itself. And then I have it over cosine squared x, which is a sine x and a sine x, and a cosine x and a cosine x. But sine squared over cosine squared is tangent squared, and tangent squared is negative. It will not simplify to any one of the other three. Which of the following is equivalent? If it's multiple choice, only one can be correct. Only one can be correct. Okay? Anything else over 3.12? Or 3.11 if you had something, I guess. 16? There's a couple ways you could go about this one. You could distribute sine squared to both. You could, if you wanted to. Sine squared times 1 is sine squared. And then cotangent squared is cosine over sine. You don't do all this stuff in your head. You need to show it on paper. But cotangent is cosine over sine, and you're multiplying it by sine, so the sines cancel, and you're just left with cosine squared. I bet 1 plus cotangent squared is one of my Pythagorean identities. And again, you need to do cosine squared plus sine squared is equal to 1. If I flip that, sometimes it doesn't matter. You can do sine squared plus cosine squared or cosine squared plus 1. Cotangent, I need cosine, so I need to divide everything by sine squared. And this gives me the 1, and this gives me the cotan. And then 1 over secant is cosecant squared. So cotangent squared plus 1 is cosecant squared. Again, there's what makes these hard, guys. There's a bunch of ways to do it. As long as you're not doing anything wrong mathematically, you're okay. So 1 plus cotangent squared is one of those easy ones that's equal to cosecant squared. Uh-oh, almost messed up. And then I'm multiplying that times sine squared. And cosecant squared is 1 over sine squared, and 1 over sine squared is times sine squared is 1. if I distribute it, I'd get the same thing because I think I ended up with cosine squared plus sine squared or something like that. Yeah, because I distributed it here, right, and I got sine squared, and this all canceled out except for the cosine squared, and I ended up with sine squared plus cosine squared, which is 1. Doesn't, how you end up with it or how you start with it doesn't matter. You're going to end up at the same spot. And there's several ways to do all of these, as long as you're not doing anything wrong mathematically. You can make cotangent squared cosine over sine squared, get common denominators if you wanted to, because you want to do what's inside parentheses first, and then distribute the sign. However you see it to be the easiest. Yay. What else? Double angles. What was it? Doubling? Oh, and that addition ones and subtraction ones. See all of it on your quiz. The solving one is not easy. But it's one you've seen before if you did your homework. It's a repeat. It's not like it's a new one. Everybody okay? Good? Happy, happy, joy, joy? Okay, we're going to do 13. So we'll do 13. We'll take our quiz. That way those of you that get done with your quiz can work on 13. Okay, so I'll talk 13, and then, of course, we'll get our minds right back for our quiz. But quiz is only 2 sections, 10 and 12. 10 was equations and inequalities, don't forget. Okay, I think this is not too difficult, but it's just something that's new to you guys. It's something that's not, you've never seen this before. So other than that, it's not difficult. It's just something you haven't seen before. So we're going to talk about polar coordinates. Polar coordinates. Your whole mathematical career, guys, y'all about done? Has been rectangular coordinates. You got an X, you got a Y, you got a point. You got an X, you got a Y, you got a point. Sometimes you got a negative X, sometimes you got a negative Y. You did rectangular points. Now we're going to do polar points, okay? If we wanted to travel from one location to another, there are several methods we could do to travel there. Walking, biking, driving, flying, boating. Each method has its own advantages and disadvantages depending on the particular situation. Additionally, each method has a specific constraints and restrictions. If we're driving from one location to another, we would have to stay on the roads, which generally formed by rectangular grid system. If we were flying, we want to just fly straight there. Ironically, fly does not really straight, it's more of an arc, but yeah. Provided there was an airport. Plotting points in the space, defining the functions is not much different than the transportation examples above. There are several ways to define points. So again, the rectangular coordinate system is what all we've used before. X's, negative X's, Y's, negative Y's. X, Y. An alternate way to describe a point in space is the polar coordinate system. So a polar coordinate system has a vertical axis and a horizontal axis, but it's not an x-axis and it's not a y-axis. Okay? With polar coordinates, we do not use x and y values to define points. The polar coordinate system is much more like flying an airplane. To define a point, we need to state the angle of the point in standard position and the signed distance of the point from the origin. In other words, we simply rotate it until we're facing the point and then draw a line directly from that point. The polar coordinate system can be very useful, especially when working with circles, trig functions, and conics. So, polar coordinate. You have a vertical axis, you have a horizontal axis, just like x's and y's, but it's not x's and y's. You always start at the origin, which is kind of nice because we are used to doing that in trig. They are going to give me an angle. some angle. We're all going to be in radians, but it could be in degrees if you were doing a ACT test or something. Of course, it's 360 all the way around. It's 2 pi all the way around. We can go negative angles. We can go positive angles. We can go all the way around and then add some more. So we could go 580, or we could go 6 pi, or we can go negative. And then R is telling you how far out you're going to go from that angle. So it's R theta. R is the radius, theta is your angle. Okay? R could be negative. That is the most trickiest thing about these. In polar coordinate system, the point A, this point out here, is defined by R theta, where R represents, and they showed the absolute value of R, represents the radius of the circle in which point A lies, and theta represents the measure of the angle in standard position whose terminal ray includes point A. Yeah, one really cool result of using polar coordinates is the same point can be represented many, many, many different ways. If I give you rectangular 1, 6, you can only go 1, 6. That is the only way to get there. You can't get there any other way. Here, you can get there infinite ways. That way. That way. That way. That way. Yay? And the tricky part is that way with negative. So you can have a negative R value. You could have a negative R value. All that does is it tells you where your angle's going, and then you're kind of turning around and going that way, as opposed to actually going to that angle. We'll cover that in just a second. Okay, so this is a polar coordinate grid. It looks different. However, you can still see the horizontal axis and the vertical axis. They just give it to you as a circle because you know you're going in some angle. Okay, you're going in some angle. Each circle represents a unit. So of course this is 0 right here. This would be 1, this would be 2, this would be 3, 4, 5, 6, 7, 8, 9. Okay, so it goes out. This is just like your regular coordinate grid. This is just only going out to 9. I could go out to 20. Negative 20. Okay, they just put 9 circles. Typically, they don't go very big. When I draw these, of course, I don't draw the whole thing, just like you don't draw the whole coordinate grid, right? When you draw a rectangular, you don't draw all the lines. When I draw these polars, I don't. I just draw the angle wherever it is, and then I'll go out 1, 2, 3, and I'll just say how many points I'm going. Okay, just kind of recognize that. Most of the time it's drawn for you. Okay, on this right here, they want me to plot and label each of those 4 points. So I don't look at the 2 first. I got to look at the pi over 3 because I got to know where my angle is going first. It's kind of different when x, y. Normally you're looking at your x's and then you go to your y's. This, you have to look at your angle first. Look at my angle, pi over 3. Well, luckily we know pi over 3 because pi over 3 is one of those that we use all the time. This one's pi over 6. Oh, here it is, pi over 6. They put some extra ones in here too. That's kind of gets a little bit more confusing. So this one's pi over 6, so I guess that one's pi over 12. Pi over 6, there's pi over 4, and there's pi over 3. So they labeled it for me. I'm okay with that. And I got to go 2 units. So here's 1 unit and here's 2 units. Uh-oh, forgot to do this part. 1, 2. And label it A. Go ahead, Jonah.
If you look at the x-coordinate line, it says 1.
Oh, it does. Oh, it does. Oh, they went by halves. I'm sorry. Y'all see that? So they didn't label it by that. Y'all see it? So the dark ones are 1, 2. Okay. Again, that's why if I was doing this without the circle, okay, that's what I would do without the circle. Okay, just going 2 units. So 1, 2. Let me erase this. 1, 2, pi over 3. Point A. Point A. So the angle's telling you which way to go, and R's telling you how far out you got to go. 3 pi over 2, 3 pi over 2, 3 pi over 2, 3 pi over 2, 3 pi over 2. That's down, that's straight down. Duck straight underneath me. And I'm going 1 unit. 1 unit. So straight down underneath me, 1 unit right there, which is B. B. You'll have to do this on the test. Just make sure we can see the dots and make sure they're labeled correctly. 4 pi over 3. 1/3, 2/3. Don't forget to count this one. 3/3, 4/3. 3 units. It's all the way out here. C. And the last one is negative pi over 6. So now instead of going up, I'm going down, negative angles. Negative pi over 6 is typically the first one, but it's the second one because they decided to add some extra ones. So this is 1/12. Here we go, 1/6. And I got to go 2 units, 1, 2 units. And that's point D. Yes, no, maybe. They're going to give you the angle, and they're going to tell you how far out to go. Those are polar points. Polar points. Go ahead and plot point A. Plot point A. Pi over 4, 2. I need to get better about this. Penny, what quadrant did I end up in for point A? Which quadrant? Don't say it like a question. Okay, y'all good? Pi over 4, 2. You wish, I hope you wish there's like 20 of these on your test. Right? There for sure is one. So you go to pi over 4, you go to 1 unit. Make sure you label it A. Most students do really well with that. Again? Dang it, it's 2. I missed it. Thank you. 2, 1, 2. Beautiful. Negative 7 pi over 4. Natalie, what quadrant did I end up in? Yeah, okay, 1? Oh, same angle? Y'all good? We can name these infinite ways. Infinite ways. Same point, yes? Interesting. Interesting. 9/4. 9/4. Jonah, what quadrant did I end up in? Oh, it is?
Yep.
Same point?
Yep.
Wow. Surely they're not going to put all 4 of them in the same point. 5 pi over 4. 5 pi over 4 is not in quadrant 1. But then it's negative 2. So my guess is 5 pi over 4 is in quadrant 3. 1/4, 2/4, 3/4, 4/4, 5/4. But then it tells me negative 2, so that means I'm right here. I'm supposed to go this way, but negative 2 tells me I got to turn around and go that way. and end up at the same point. The negative ones are by far the most missed. You just got to think to yourself, well, I'm not going to go that way. I'm actually going to turn around and go the other way. There are infinite ways to label those points, as you can see. All 4 of those are the exact same point. Okay? All 4 are the same point. And I could have labeled them infinite ways. Infinite. I've learned. I'm not even going to do it till he gets done. Bless you. I didn't label them all. Sorry. I should have. B, C, D. Beautiful. Example 2 illustrates how a single polar point can be expressed in many different ways. In fact, there are infinite ways that we could label those polar points. Okay. Plot the point with polar coordinates 3, 5 pi over 6 on the polar coordinate, and then write it 2 different ways. Write it 2 different ways. AP will tell you, they'll give you restrictions. They'll say you must have a negative R and a negative theta. AP will give you restrictions telling you one must be a negative R and one must be a negative theta. Now you can do both, but that won't get you 2 ways. All right, so 5 pi over 6, 5 pi over 6, 5 pi over 6, 5 pi over 6, 5 pi over 6. Quadrant. Grace? Yeah, because 6, 6 is on the x-axis. So 5, 6 is just before it. So quadrant 2, right? Quadrant 2, and it's the one that's close to the x-axis. Again, notice that they put 6th here, so it's 6th here, and I got to go 3 units. 1, 2, 3. Damn it. Tucker, I get that one right finally? I've missed the first 2. Oh, they didn't give me a point for that one. So I'm going to label it, but I put it on the graph. And I got to label it 2 different ways. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. And I went down so I could label that. Again, there's infinite answers here, guys. Infinite. Negative 7 pi over 6, 3. Little bit different in the fact of it's R theta. Don't put theta R. R is first, which is a little weird because we're used to doing X, Y, and we're used to doing the X first. And really, you can't do 3 first. You got to do the angle first before you can do the 3. That's one way, right? And the other way is to go to quadrant 4. You can go negative or you can go positive, because your instructions on AP will typically say one of R must be theta and one of R's must be negative and one of theta's must be negative. At least one. Yes?
Will the test also have a question like that?
Say again?
Will the test also have a question like that?
Yes. Yeah. Yeah, that's why I say they'll put restrictions on it. They'll put restrictions on it so that we can't have 8,000 different answers. Bless you. I know, I'm lucky. Okay. Little bit more difficult of a situation right here, okay? Rectangular coordinates. Rectangular. You're given as X, Y. X, Y. X, Y. So there's point A with X, Y. Point R won't be X, Y. It's going to be theta R. But hopefully we can easily see this relationship, because this relationship is still going to put me an X here and a Y here and an R here, or z or ABC or however you want to talk about that, right? X squared plus y squared is equal to r squared. We also know that cosine of this angle is equal to x over r. We know that sine of this angle is y over r. All this stuff you already know, SOHCAHTOA. It's used a ton in trig. We know that tangent of this is this over this. If you know all that stuff, you converting them from polar to rectangular and rectangular to polar is fairly simple. It's a fairly simple process. The image on the far right shows us the connections between polar and rectangular. Using this, we can quickly find relationships that allow us to convert between polar and rectangular, rectangular and polar. Here's where they're telling us that same thing, right? This is x, this is y, this is theta. And of course, x could be negative, y could be negative, r could be negative, but most of the time it's not. The only way r would be negative is I'm not finding this angle, I'm finding this angle. You know that cosine of theta is equal to x over r, and I could multiply both sides by r. If you multiply both sides by r, then you get x is equal to r cosine theta. If you multiply both sides by r here, you'll get y is equal to r sine theta. But I don't use this because I don't remember this, but I remember this. And if you remember this, you to come to this is really, really easy. But I don't use this. I just use this. Let me show you. Convert the following points from polar. So I changed mine to vertical. Yours are horizontal. I've got to convert this from polar to rectangular. Biggest hint I can give you is to draw it. The biggest hint I can give you is to draw it. Because if you don't draw it, you're going to mess up with a negative. You will. Okay? So, pi 2. Pi 2. This one I think is really, really easy. I don't even need to use SOHCAHTOA stuff because pi is over here. And 2 units is right here. And if I'm going to convert that to rectangular, -2, 0. I could have told you that, like I would have said, name that point before you came to class today. I would hope that everybody could say that's -2, 0. So polar, it's 2 pi. Rectangular, it's -2, 0. Hopefully you understand why drawing it will help you. Draw it. 5/3, 1/3, 2/3, 3/3, 4/3, 5/3. 4. I need that distance, and I need that distance. This is 5/3. This must be 1/3. Sine of 1/3 is 1/2. No, square root of 3 over 2. But we had to quadruple it. It's square root of 3 over 2, and this is 1/2. This is 1/2. This is square root of 3 over 2, but this is 1. But it's not 1. It's 4. So this is no longer 1/2. This is now 2. And this is no longer root 3 over 4. This is 4 times root 3 over 2. We're quadrupling it. It was similar triangles. Holy cow, this geometry. I hate the geometry. Sorry. Normally that's 1/2. Normally that's root 3 over 2. And this is 1. Well, now this is 4. So everything just gets quadrupled. So instead of this being 1/2, it's 1/2 times 4. Instead of this being root 3 over 2, it's now root 3 over 2 times 4. And if you got to put more work on there to do that, then that's fine. This is the x point. And if you want to show the x point is 1/2 times 4, that's okay. And this is root 3 over 2. Careful, though. This is where we mess up sometimes, because that's really not root 3 over 2. That's negative root 3 over 2. And that's why I say drawing it will help you. So this is root 3 over 2, but I had to quadruple it, which is 4. And so 1/2 times 4 is simply 2. And root 3 over 2 times 4 is simply 2 root 3. But again, it's negative. It's negative. We knew x was going to be positive. You knew y was going to be negative to get to this point down here. They're going to give you an angle you know the values of. It's going to give you the force, they're going to give you the thirds, they're going to give you the sixths, or they're going to give you an axis. If you can't, you have to use a calculator. Seven sixths, 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6. I would put in my head already that both of these better be negative. And if this is 1/6, this is 1/2, and this is root 3 over 2. But it's negative. And this is, but it's negative 3, cuss. Negative 3 now puts it in quadrant 1. That's okay. This is still 1/2, and this is still root 3 over 2, and this is 3. So if that's 3, then this is 3 times that, and this is 3 times that. And now it's not going to be negatives. They're going to be positives. And so to get out on my x, it's 3 times root 3 over 2. And to get up to my y, it's 3 times 1/2. Question about that? Hopefully you are comfortable with that unit circle. I've told you guys, you just gotta get to where you know it. If it's the 6, this is the short, that's the long. If this is a short, that has to be the 1/2. If this is the long, it has to be the root 3 over 2. Except this is not 1, it's 3, so we just gotta triple everything. Good? Now rectangular. Rectangular. Converting to polar. -2, 2. Well, that's easy. Because when that's 2 and that's 2, that must mean we're at the 4th of an angle. We're right in between it. And this is 1/4, 2/4. That's a 3/4 angle. Don't forget the pi. Oh, and if this is 2 and this is 2, now I got to figure out the hypotenuse. 2 squared is 4. 2 squared is 4. 4 plus 4 is 8. Got to take the square root of it. They may want to root 2, I don't know. If you end up at the even ones, that's pretty easy because that's the force. Fourths. This one is not. One root 3. One squared is 1. Root 3 squared is 3. 3 Plus 1 is 4. Square root of 4 is 2. Pythagorean theorem. We just got to figure out that angle. And if this is the long, root 3 is bigger than root 1. Root 3 is bigger than root 1. So if root 3, is bigger than root 1, or you could do sine over cosine, or you could do, if I wanted cosine, it's this over this. Oh, 1/2. Sine is this over this. Oh, root 3 over 2. Oh. So when this is 1/2 and this is root 3 over 2, this angle is one of two things. You can just go negative or you can go positive all the way around. Either way. And I think it's easier just to go the negative. And that puts me at the third. That is not the only answer. You could have gone all around positive, and you can go around 4 times if you want to. One more. Oh, this is the easy one. 1, 0, -5. 1, 2, 3, 4, 5. 0, -5. (3 pi over 2), -pi over 2. You could have done pi over 2, -5. You could have done -3 pi over 2, -5. Infinite ways to label those. That's what I'll do, but you might want -pi over 2 just as easy. Yes, no, maybe? Eight o'clock. Okay, last thing, complex numbers. Complex numbers, guys, are basically, they're the imaginaries. Just keep in your heads, complex or imaginaries. You don't see these very often. Previously, we've written complex numbers in the form of a plus bi, where a and b are constants. A complex number can be understood as a point on the complex plane. This is the x-axis. This is the y-axis. X, I. So if it was a plus bi, I would go to a and then I would go to b. In other words, this is written as 3 plus 2i. 3 plus 2i. It looks a whole lot more complicated than it is. It's really, really easy. There it is. 3 plus 2i can be represented as the point 3, 2 in a rectangular coordinate system, even though it's an I. If it was 3 minus 2i, you would still go to 3, but then you would go to -2. And if it was -3 plus 2, you would go to -3 plus 2. Just like you would think. Nothing's flipped, nothing. Earlier with these notes, we learned that x is equal to r cosine theta and y is equal to r sine theta. And if you didn't know that, you know that r, or cosine theta, is x over r. Sine is y over r, opposite over hypotenuse. Using these identities, we can also represent the polar. I don't use those identities. A complex number is written by the point in complex plane. The complex number has a rectangular of -2, 2. That's the complex number, which is just like you would think. In fact, if they didn't tell me that was complex, it looks rectangular. If they didn't tell me that was complex, it looks rectangular. Okay? What is one way to express the complex number using its polar coordinates? Well, let's go to that angle, which is 1/4, 2/4, 3/4, 4/4, 5/4. 5/4. And if this is 2 and this is 2, that's 4, that's 4, that's 4. This has to be root 8. Radius has to be root 8. How do you know it's not negative? It's always positive unless if I'm going up here. Then it's negative. So I'm just keeping it there to make it positive. This is where you're going to have to use just a little bit. You know that cosine of theta is equal to adjacent over hypotenuse. And if you multiply by r, then you'll get this r. Okay? Huh? What number is what? This is r. Cosine theta equals x. Over, it went away. That was r. That wasn't r. I multiplied both sides by r. Sorry, I did that way too fast. I'm sorry. Cosine theta is equal to adjacent over hypotenuse. I multiplied both sides by the hypotenuse to get rid of it. X. R is now root 8. Cosine. 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths. That's the x. Let's put, I don't want to put the comma. Plus root 8 sine 5 pi over 4. They may leave your answer like that. Maybe. I need an I. Sorry. I need the I. It's imaginary. They may leave it like that. If they don't leave it like that, I don't like this example because this example looks like it's the same thing. Cosine of 5 pi over 4. Negative root 2 over 2. Negative root 2 over 2. Uh-oh, sorry. Negative root 2 over 2. Sine negative root 2 over 2. I don't know how I'm at general math, but you guys are probably not at general math, but root 8 is 2 root 2. And if this is 2 root 2, and this 2 gets this 2, and root 2 times root 2 is root 4, which is root 4 is 2. It simplifies to 2. Negative. Negative.
That's the same thing.
That's your answer. That's complex form. I'll go through it again. I'll go through it again. Okay. Shh. Hang with me. All right. Rectangular. Nope. The complex number has a rectangular form -2, 2. So it's actually -2, -2i, but we'll go -2, -2. Okay. negative 2, which gives me the hypotenuse of 8, root 8. So once you have negative 2, root 8. Okay, we got negative 2, root 8. Your x point, or your cosine point, r cosine theta. R cosine theta. R sine theta is your y point. So r is root 8. Cosine theta is 5 pi over 4. There's the imaginary part. The second part's imaginary. The second part's always imaginary. R sine theta. And if you can get r cosine theta and r sine theta, that could be the answer. And if it's not the answer, you just simplify it. Cosine of 5 pi over 4 is root 2 over 2, negative. Root 2 over 2 times root 8 is just simply 2. That's the hard part for you guys because it's math. I simplify that. One more. Now I'm in complex. Hit me.
How is it any different from, so if it gives you the coordinate points,
Yep.
you know it's on a complex grid,
Yep.
then you already know how to express it with I.
Yep.
So why
That
do
one's
you do all
special because it was a 45 though. But just hang with me. Gentlemen. R cosine theta plus I R sine theta. Express it using polar. I'm sorry, use it rectangular. So, easiest way. Cosine of 7 pi over 4, which you are, or 7 pi over 6, which you already know what that is. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. Cosine is negative root 3 over 2. 4 negative root 3 over 2. I 4 negative 1/2. Negative 2 root 3. Negative 2. Yay. Negative 2 root 3, negative 2. Just convert it, drop the I, drop the parentheses. This could be the answer. These are going to be multiple choice questions. That could be the answer. And if you don't see that, then you'll see this. You'll get some homework questions to try.